in 3.1 example 1, they just want us to be able to, first identify polynomials and then talk about a few characteristics of that equation. So I'm actually just going to identify the ones that aren't polynomials right out of the way. A is not polynomial. And the easiest way to describe that is our variable is inside a radical. So that would be a radical function. Not too bad, right? I mean, typically it's easy to identify which aren't. C is not polynomial as well. Polynomial. And again, just trying to justify this a little bit, I'm going to say that the variable is inside an absolute value, which makes it an absolute value function. Absolute value. Okay, not too bad, right? Nice, I think pretty easy to recognize that looking at, you can even look at the exponent on the variable. I just would like to write another way of writing g of x here. For a would be, we could write it as x to the power of 1/2 plus 5. And that's a great way to see that the exponent on the variable is not a whole number, right? 1/2 is a rational number. All right, so it does mean that, I hope it means logically that b and d are polynomials. So for b, I'm just going to put maybe yes, I suppose. Exponents are natural numbers. Exponents are, they are our natural numbers. There's only one natural number. I'll use the hashtag there. And then it wants us to state the leading coefficient, the degree, and the constant. All right, now I'm going to do degree first. It is just the highest exponent on x, so that would be degree 4. There's only one exponent on x there. The leading coefficient is the coefficient on the term that contains the variable to the power of the degree. Now, for b, there is only one term, so the leading coefficient is its coefficient, which is positive 3. For my constant, the constant term is just that. It's the term that doesn't change regardless of the value of the variable. And even though we don't write it, you could make the argument that you could present f of x as 3x to the power of 4. And I know this seems a little weird, but I'm going to write it as 0x cubed plus 0x squared plus 0x plus 0. Now that's a lot of zeros, and we don't write that, right? Don't start writing all your functions like this. But I think it is a little more helpful to see that, 3 is the highest coefficient on a variable, because the rest of them are 0. And the constant term, because it is not written, it is 0 as well. The reason why this is so important, I'm just going to put underneath it that the constant term is always going to be the y-intercept of our polynomials. Because if I put x or 0 in for x, every term that contains the factor x is going to be 0, right? 0 times anything is 0. All right, the last one here, which is part D, and I'll write it again, is y equals 2x cubed plus 3x squared minus 4x minus 1. It is polynomial because all the exponents are natural numbers. We have 3, 2, and 1. My leading coefficient, I forgot the degree. My degree is going to be the highest exponent on an x, so that's the 3. Oops. It's the 3. And I'm just going to put cubic beside that so we learn a little more notation. While I'm at it, let's put quartic up here because that is degree 4. The leading coefficient. Now, because I know the degree, it's cubic, the leading coefficient is whatever coefficient is on my x cubed term, or my term containing x cubed. In that case, that's going to be positive 2. When we talk about leading coefficient for the rest of chapter 3, what we're really going to care about is whether the leading coefficient is positive or negative. That's going to guide us to the end behavior of these polynomials. And then the last part is the constant term. In this case, that is going to be -1. And I'd like to identify that it means the point 0, -1 is my y-intercept. Now, I didn't do that over here, but I'm going to do it. My y-intercept in this case would be 0, 0. That is a nice, quick point to be able to identify. You have actually already learned that constant concept. Back in 20-1 in chapter 3, we talked about how a constant in a quadratic in general form ends up being the y-intercept of that graph. So just some, I would call this a housekeeping lesson where we want to make sure that we're using the same terminology as we start to talk about these polynomials and examine their behaviors.